A little while ago, I talked about a space phenomena known as the black hole, and today I want to talk about a few more interesting space things. Welcome to episode 17 of Dyllon Explains Everything. My name's Dylan, in case you couldn't tell by the title. I'm the one explaining everything, including the topic of today, strange space stuff. I'm going to be running through a lot of facts, so if you're curious as to where I get my information, be sure to check the description below for a list of links. So what do I mean by strange space stuff? Well, I'm mainly talking about stuff in space that is strange, or to put it more professionally, astral objects that exhibit abnormal properties or out of ordinary behavior. The first strange space thing I want to talk about is Tabby's Star, or KIC 8462852. Which is named after the researcher Tabithas Star, who leads the research on Tabby's Star. Now, this star isn't a normal star. It exhibits some interesting properties. Tabby's Star is a medium-sized star that's 50% bigger and 1,000 degrees hotter than our sun, and it's about 1,000 light years away, making it really hard to research and causing a huge disagreement in astronomy. Basically, back in 2016-ish, when Tabby's Star was found, there was an interesting property that it was showing. Its brightness was constantly and inconsistently decreasing and increasing, but over time mostly decreasing, to the point where over a few days it dimmed a whole 1%. This sparked many theories from astronomers, scientists, and conspiracy theorists, including the theory that there was a Dyson Sphere around the star. Now, in case you don't remember what a Dyson Sphere is, from my black holes video, allow me to explain. A Dyson Sphere is a giant metal encasing we would put around the sun in order to gather energy from it, like a giant solar panel. And a Dyson swarm is the same thing, but in a swarm shape. A bunch of solar panels surrounding the sun like the rings of Saturn, but bigger. This allows a civilization to advance on the Kardashev Scale. Now, if you don't remember what the Kardashev Scale is from my black holes video, it's basically a scale made by a guy named Nikolai Kardashev that rates civilizations and species based on how much energy they can produce. The widely accepted scale has 3 types on it. A Type 1 civilization, which can get all the energy from its planet, a Type 2 civilization, which can extract all the energy from its solar system, and a Type 3 civilization, which can get all the energy from its galaxy. Type 0, which would be able to produce no energy, has also been proposed but not yet added to the Kardashev scale. This would allow us to put civilizations that can't even produce fire on the Kardashev scale, and allow us to accurately place Earth, which would be a 0.7 on the Kardashev scale, since we haven't extracted all the energy from our planet, but we're fairly close to it. A Type 4 through 10 has also been proposed, but never added. This all goes back to a theory of a Type 2 or maybe even 3 civilization putting a Dyson Sphere around Tabby's Star, which would make the brightness of the star dim due to the amount of energy they'd be gathering. Of course, scientists eventually debunked this, which it's weird to me how they can debunk something that's 1,000 light years away quicker than aliens building pyramids right here on Earth. Another theory that was proposed is a protoplanetary disk, which is basically a huge cylinder of dust that would be surrounding the star. The problem is this only happens with newly made stars, and Tabby's Star is definitely not a newly made star. Another theory was comets like Sozin's comets, which could be constantly flying in between Tabby's Star and us, spewing off space dust. The problem with this is this doesn't explain long-term dimming, since Tabby's Star has actually dimmed 20 to 30% since it's been founded, so it's definitely not comets. So this takes us back to the alien Dyson Sphere theory, which how did they even disprove that before? Well, it turns out a Dyson Sphere would be opaque, letting no light through, but we can still see light, it's just a lot less of it. So it's definitely not a Dyson Sphere. Scientists have almost certainly nailed this down to space dust. Basically, the blue light that's coming through is dimming, while the red light is mostly untouched. This only happens with space dust between us and the object we're trying to observe, but this still doesn't explain how the dust got there. The 2 main theories I found as to why this all is one, a moon that could be flying around the sun, constantly emitting off space dust if it just starts disintegrating out of nowhere, meaning that eventually all the dust will go away and we'll be able to see Tabby's Star back to normal. The other theory is that Tabby's star was actually fueled by something that made it brighter, and now it's going back to how it originally was. While we don't know the true culprit behind Tabby's star's strange properties, we do know that most likely it's dust. Now, it's time to move on to our next strange space stuff thing. I need to come up with better names for these. It is Boötes Void, or the Great Void. Basically, when we think of space, we think that it has a lot of, well, space. But the truth is, in the scale of light years, galaxies are not that far from one another. When you go past one, there's another one just on the other side, except for in a few regions of space, like Boötes Void. Boötes Void, or the Great Void, was found by a scientist named Robert Krishner and is located 700 million light years from Earth and is a large 250 million diameter sphere of almost nothingness. So basically, Boötes Void is 27% of a percent of the observable universe, which might not sound like a lot, but considering that the observable universe is around 300 billion light years in diameter, it's pretty big. In order to explain to you just how big this truly is, I need to explain what a parsec is. Now, a parsec comes from two words, parallax and arcsecond. And yes, I know that's technically three words, but just work with me here. Parallax is basically the measure of how much something changes when you change your perspective of it. For example, if you're right here looking at the neighbors of your neighbors across the street, you see this one is being on the left and this one is being on the right. But if you go into your neighbor's backyard, first of all, you get fined for trespassing, and second of all, they swap positions when you're looking at them. This one becomes left and this one becomes right. This all has to do with relativity. To put it in simple terms, when you move, everything around you moves relative to you, and in physics, that means it's technically moving, which is kind of weird, but Einstein said it, so it must be true. So when scientists measure something in space, they'll measure it at one point in time, let's say December, and then they'll measure again 6 months later, so in this case June, and then they'll find the parallax so they can find out where the object really is. With me so far? Great. An arcsecond is based on degrees. Basically, we know that there's 360 degrees in a circle. So when we're measuring in space, we can use a degree based on where we're looking at. An arc minute is 1/60th of a degree, or about 1/30th the width of the moon. An arcsecond is 1/60th of that, or about 1/1800th the width of the moon. Basically, this means that a parsec is the distance between two objects where the parallax of the objects is 1 arcsecond. And if you understand that, great for you. Basically, what I'm trying to say is it's really big. 30.8 trillion kilometers, or 19.1 trillion miles. Now, a megaparsec is about 1 million parsecs, or 9 quintillion miles. This number is so big, it's lost all meaning because we can't even comprehend it. And to say that this is actually 236,000 megaparsecs cubed, or about 4.5 septillion miles cubed, means nothing to us because of how enormous that is. Scientists have actually found all the galaxies inside of Boötes Void, and there's a total of 60 of them. That's like finding 60 houses in the entirety of the United States. It is so small. And the thing is, if we were at the center of Boötes Void, we wouldn't see another galaxy until the 60s, unlike normally when we can see tons of them just looking up at the night sky. And that's assuming we would be interested in astronomy at all in a world where we can't even see galaxies. So obviously people want an explanation, right? How did this happen? Well, the truth is we have no idea. I mean, we have a few theories, but nothing substantial really. We do know how smaller voids form, though. Basically what happens is the void doesn't have as much gravity as the surrounding areas. So over time, those areas start picking away at the galaxies that are inside of this area, and slowly but surely it loses even more mass until eventually it has almost no galaxies inside of it. The problem is this doesn't explain Boötes Void, simply because even scientists admit that the universe hasn't been around long enough for that to happen on that big of a scale. Scientists have noticed a weird formation in the galaxies inside of Boötes Void, leading to a new theory. They think of something called the soap bubble effect. Basically, a bunch of smaller voids were formed and eventually got so close together that they clustered into one ginormous void, kind of like soap bubbles coming together to form one big soap bubble. Of course, we do have the theory of aliens. Some people think that maybe at the center of Boötes void there was a civilization that became a Type 3 civilization and started creating Dyson spheres around the galaxies inside of Boötes void, which would explain why it's such a nice sphere of near nothingness. This theory is like the Tabby Star theory, but on steroids. I mean, even if they had billions of years, this would take really long and require a lot of work to accomplish, but it's not out of the question yet. The void is so empty and consists of so much nothingness that if a particle entered the void, a few things would happen. Number one, the particle probably wouldn't encounter another particle ever, unless it exited the void, which is very unlikely. But if it did, number two, it would look the exact same as when it entered because of the vacuum conditions. Whether you think that Tabby Star and the Great Void are products of Dyson spheres, or you think that scientists came up with reasonable explanations for all of this, or maybe you just don't care and all of this is boring to you, all of these questions have plagued scientists for years. With all that being said, I hope you enjoyed today's video just as much as aliens like to colonize, Britain. With all that being said, I hope you enjoyed today's video just as much as aliens enjoy building Dyson spheres inside of the Great Void. And if you did, be sure to let me know, and stay tuned for my weekly videos always coming out on Saturday at 10 a.m. Be sure to leave any thoughts, questions, or suggestions in the comments below, and remember, my name's Dylan and I explain everything.